Okay, so I hope you all are well. And in this video, we try to know about the area of these figures, and how this concept is made, and how we can calculate the area. What's happened behind the scene, so that we can say that this is the area of a square, or this is the area of rectangle, or this is the area of cuboid, or this is the area of cube. Okay, so the first thing we have to know about the area. Okay, what is area? So the area is nothing but the total space that is occupied by the figure. Okay. So there is two concept, area and volume. In volume, we go in next videos, in further videos, but in this video, we just only talk about the area. So area is something which is occupied by the figure. Okay. So that is the area only. Yeah. So we try to understand the concept of area. Okay. Okay. We try to understand it. Okay. Suppose this is one scale. Okay. Or you can say that this is one line. Okay. And this line is nothing but a single dimensional figure. So in one dimension is which have only one thing to measure. Like this scale have only length. Okay, like 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, or a meter, or in a kilometer, anything. Okay. Now what about the two dimension? Two dimension is which have a two thing to measure, like length and breadth. Okay, length and breadth. So this is also have a two dimensional figure. This also have a two things to measure, length and breadth. Or you can say that the two component with the help of which you can measure the area of it. Yeah. Now this is the three-dimensional figure. Now this figure have a more than two, because this is three. Yeah. So this, like, one thing is this. Okay. What is this? This is nothing but you can say that height. Okay. This is nothing but the breadth. Okay. And this is nothing but the length. Okay. So you can say that this figure also have a three things to measure: one, two, and three: length, breadth, and height. Okay. So this is the three-dimensional figure. This is the three-dimensional. And generally in our real life, three-dimensional figures are only exist because we can then only we can measure them and touch them. On then the concept comes of two dimension, it is a little bit complicated, so we can't discuss about it. Okay, so now this is the two dimensional figure, and you can say that there is a length also and breadth also. Now what happening? Okay, now first thing we have to just we go through that. So what is the area of? Now we have to, so the formula of calculating the area of it, suppose there one side is a and the other side also a, because the both side in a square, every side is of equal side. Okay, sorry, what happening? Okay, the both sides are okay. Yes, so square, every side is equal length, so the area of a square is nothing but the a into a. But why there is now a into a? Why not the a divided by a or a plus y? Why the only area of a square is a into a? So here I write in some other word. Okay, yeah, the area of each square is a cos a. Okay, this is the area of a square. Okay, yeah. Why it is a into a only? Why? So suppose this is one scale. Okay, and this is the smallest unit which we can able to measure, and then we replicate this unit again and again and again and again and again and add it. Okay, so suppose this unit nothing but 1 centimeter, and then we replicate it again and again and again and add it. So you can say that this is the 1 meter, this is the two one again meter, this is the one again meter, this is the again meter, this is again meter. So it is nothing but 1 2 3 4 5 6, the 6 meter scale. You can say that 6 centimeter scale or 6 meter, what you want to take, so take it. Okay, so here the concept of measurement comes in this way. Okay, now the concept of area comes. How? So the one dimensional figure you measure like this. Now the nothing is nothing what nothing more complicated. Just what we done, we make again one line. Okay, just I try to make it. Yeah. So just we make it again one line. Okay, little bit more big. Okay. Just I want to make it equal to that line only. Yeah. So this is one line. Now what? We consider the thing only. The one thing only we consider is that this is the smallest part that we can measure. This can be more smaller, like this in microscopic level. But for general purpose, we consider only this. This is the smallest part which we can measure. We humans as humans are able to measure only this portion. Okay, so we consider this, and with the help of that, we can get okay the one, 3, 4, 5. Yeah, the 1, 2, 3, 4, 5, and 6. One, a little bit more big. So no problem. We just increase it. Oh, yeah, we just increase this line. Okay, yeah. So now you can see that it's a two-dimensional thing. One dimension, two dimensions. Okay, and you can say that this is the smallest unit. This is the smallest unit which can be measured. And then we add them, and we can able to measure complete length of this scale or this line. You can say that. Okay. Now what we done? They just multiplied this line. Okay. So what happens when they multiplied it? What happens when we multiply these lines with each other? Okay, when you multiply this line with this line, okay, it means you calculated the every point of this line, or you add every point of this line, you measure the every point of this line with this line. Okay, so now you can able to create. Okay, now you can now when you, yeah, I am sorry, I'm a little bit try to do things in a perfection way. So when you multiplied every point with every point, it means you getting the answer of its inner space, like the space between this. Okay, it's the only way. Now what happens in generally what happens, like when you multiply one, okay, with like six. Okay, so suppose this one is of this line, six of this line. So you just replicating one with this all 6 points. Okay, so this multiplied by this all 6 points. So now this line and this line comes in under this whole portion. Okay, from here to here. Okay, try to understand what I'm trying to say. Suppose we just know this area, the smallest area that can be measured by us, and then we replicate it and make it measure the complete line. Okay, then similar we do with this line. Okay, so this is the square. Okay, this line and this line. Now we have to understand about so when we multiplied every point of this line with this line, when we multiplied every point of this line with this line, then only we just replicating every point of it with this much time. We just replicating every point of every this line. We just replicating this much time, so that this line is now here also, 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 now here also. So you can say that when you replicated this line, suppose this is the 1 unit, this is the all 6 unit, so you are doing nothing but this. Okay, you are doing nothing but this. Okay, you are doing nothing but this thing you are doing. Okay, you are doing nothing but this thing is you are doing. The area counting is not many big thing. Just I'm try to making you understanding that behind the scene, behind the formula scene, so that you can and this concept you get very well that never you if anybody give you any new figure, then also you can make formula your own. If you forget the formula, you can make it your own. So 1 into 6 is nothing but one and replicate it by 6 times, like 1, 2, 3, 4, 5, 6. Okay, so now the every line is this whole. This the one line, and multiplying by 6 means 1, 2, 3, 4, 5, 6. So it means nothing but you making this. So now you get this area. Okay, so 6 unit. Okay, so 6 unit is the measurement of this area. Okay, this is 1 into 6. We same thing we do with this, 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 and we get the area of whole. Okay, whole. So try to understand this is the portion which we can measure, or we make this as a single unit. We make this as the 1 unit. You can say the 1 meter. Meter is a unit. So generally I representing all the unit like meter, centimeter, kilometer. So for that I say that it's the 1 unit. Okay, or you can say the 1 meter. And the 1 meter is the smallest quantity that can be measured or made the human to measure anything. Okay, generally. So for any line, the smallest thing we can measure is 1 meter, and then we replicate it, make it a 7 meter, 6 meter, 10 meter, or add one, you can get 100 meters of it. Okay, so this is the concept, and then we multiply it, so we get the whole area. How? Because now we measure this area also, this area also, this area, this by 1 into 1, like one is this, one is this, so one is this, one is this, like again one is this, one is this, so again one is this and one is this. So you can see that 1, 2, 3, 4, 5, 6. Okay, six box you get. So 1 into 6 is 6 only. So you can see that this is one and this is all 6 meter line. So 1 into 6 is 6 meters. So this is the concept of area. So now you had measured the area of this person. Okay, similarly we done with this complete area. So you get, okay, you get the area of this complete portion. Okay, Yeah, you get the area of this complete portion. And similarly, just what you want, you have to now. In this case, you have to measure only with you multiply this whole line with this only, so you get this. Now you have to multiply with this complete, okay, and this complete, so you get the whole. This is the most basic, and it is like little bit a high level of thinking. What I'm extra to explaining it. Okay, so this is nothing but the area, and that in this way only we measure the area, and the concept of area comes in our life. Okay, now now the similar way we go to rectangle. So in rectangle, the opposite sides are equal. Okay, like this side, this side, this side, this side. Okay, these are the equal sides. So I make it them in a same color. This and this. Okay, so you can see that these sides are equal, these sides are equal. So similarly, suppose this side is of 4 unit, this side of 6 unit. Here the both sides are of 6 unit, but in this side suppose it's a 6 unit and this side of 8 unit. So now the area of it is nothing but the multiplication of these lines. So the area of rectangle is, I'm just writing here only. Okay, so the area of rectangle is nothing but L into B. Yeah, the area of rectangle is this. Okay, so I just replace this thing. I want to replace it, so I can write here only the whole area. Yeah, cut it. And now this is little bit far. Okay, and here I write it something to write something. Sorry, area figures, area of figure. Okay, area of figures. I don't know if it's figure. Yeah. So similarly, this side is L and this side is B. Okay. Okay. No problem. So this side is L. I write here L. Okay. And this side is nothing but, sorry, this side is nothing but the B. You can say the breadth. This is length and this is breadth. Okay. So this is the area of rectangle. Now the area of cube. Now from the figure you can say that cube is nothing but in cube also the same concept comes like in a square. Every sides are equal in size. Okay. So similarly, what happens if the square you put here, now you can see that there's in cube nothing but there is a six squares, nothing but the cube made up of six squares. When you join six squares in every side, it forms as a cube. Okay, so from that you can understand if the area of a square is a into a, then there is only six squares in cube. So the area of what mm, mm, cube is of nothing but six a square. Okay, when you multiply thing with itself, it means it's square. It when you multiply things with itself, it means that is you make its own square. That's why we call this as a square, because we multiplying same thing with same thing. Like this length is same, this length is same, so a into a is a square. Okay, because in generally, if you somebody says give me the square of 3, it means nothing but the 3 into 3 equal to 9. So 9 is the square of 3, because you multiply 3 with 3, so you get 9. You can understand that square is nothing but when you multiply things with itself. Here also you multiplying thing with itself. So the area of cube is nothing but 6 into a square. It means a into a. Okay, now the cuboid. Now the area of cuboid. So here the cuboid, you can see that cuboid is nothing but made up of the rectangles. But here the cube, because the sides of square is similar, so you can see that every side there is a one square. But in cube, you can see that these sides, this portion, literally I'm just trying to fill it. Okay, huh? So you can see that this portion, okay, is equal. This portion is equal. This portion is equal. Okay, and the front portion, which I can't. Okay, these. Oh, sorry, sorry. Yeah. So these portions are of same cuboid, but these portions are not of same cuboid. They have something different on it. So what happening here? So here nothing. The thing is happening is that this and this made this cuboid. Okay, this side and this side make this cuboid. Okay, so when you measure, suppose this above portion, when you measure, when you try to measure this above portion, this portion. Oh, sorry. Okay, okay, no problem. This portion. When you try to measure this portion, so here, uh, so this portion nothing but this side and this side multiplication of this side. So we consider this side as a. So we consider this side as a, suppose this side as a L. Okay, and this side as a breadth, okay, or you can say width. Oh, what's happening here? Why it is not working? No problem. Because this side has a width. So now the area of this is nothing but the L. Oh, sorry, L into mm, breadth. Okay. Similarly for this side also. So you can see that this and this is nothing but the two. Okay. So you can see there because there are the two same faces. Opposite faces always same in keyword. Okay. Yeah. Now similarly for this and this portion also. So you can do this is the breadth. So for this figure also this is the breadth. But now what about this? What about this we consider as a suppose this side we consider as a edge. Okay. No problem. What happening here? What is happening here? I don't know. Yeah. So this side we consider as a edge. Okay. Oh yeah, no. Consider here. Yeah, now I put it on. Uh, I don't know what happens to my laptop. It is not working too much good way. Yeah. So this side consider as edge. So now the area of this portion is nothing but the B into H. Okay. So the area of this portion is now nothing but the B into H. So we consider as a B into H. And again, there is a two similar face. This face is opposite face keyword always the same. So here also the one concept comes in we multiplied it two because there is a two faces. Okay. Now same thing we have to done for this portion which is on our side and backward side. The face which is facing us and backward face. So for that you can see that this is nothing but the length and this is the height for this face and the similar for the backward face. Okay. So here is nothing but the two because again this is also two L and into H. One thing also we have to done is plus. Okay. Yeah. So sorry. Yeah. So this is the area of cuboid. Now in questions when we try to solve the question, the two three concept comes in cuboid. Okay, the lateral surface area. So in lateral surface area, what happens? This the upper face and the down face is neglected. Like in keyword, there is no upper face or the down face. Like suppose this keyword is of like your room is on keyword face. Okay, so in keyword there is one is ceiling and one is like land or base. So suppose in your room there is no ceiling and no ground. Then what happens? You have to you have to discard these two things. Or you can say that these two things if the side walls are not there in your room. Okay, so you have to discard first. And then this is the lateral surface area. Like in question, you can say that you have a room and there is no ceiling. It means you have to neglect this area. Now you don't count this area. So what happens? Suppose in this keyword L into B, B is this, L is this. So now you have to neglect this. So where is L into B? L into B is this. So you subtract this means you discard this portion. When you discard this portion, now only left this portion. Okay, now only left which portion? This portion. Now this is the area of your cuboid, or you can say that the lateral surface area of cuboid. Lateral surface area. Okay, so this is nothing but the lateral surface area, and this whole is the total surface area. This whole is the total. Similarly in cuboid, if somebody says I don't want the area of this portion, just you subtract this portion. What does mean? Now the one square is subtracted, so now from 6 there is a 5 only. If they subtract this and this area, this surface area, then it is a 4a square because you subtracted two areas. Similarly here, when if somebody subtract you from like this face and this face, so L into B, L into B here, so you subtract this, or somebody try to subtract this, so this is what H into B, so you subtract H, where is H into B, this area only. If somebody subtract only one portion of it, so from two it is only one, so just in place of two you write one. Okay, so this is the total concept of area. Okay. In next video, we go through some more difficult questions of area, surface areas like cube. We covered the cube now, the cylinder, circle, and triangle. Okay. Thank you.